Okay, so I want to solve a slightly mathematical question, which I've lifted from the Jakers book. Now, in the question, which you can see on the screen, I have a supply function and a demand function. I'm going to begin by solving for the equilibrium, which is what part one of the question requires me to do. In order to solve for the equilibrium, I need to assume that the quantity demanded is equal to the quantity supplied. In other words, the theoretical equilibrium holds. If I do that, I can set the two equations equal to each other. Now, here the equations are inversed. That's absolutely no problem at all. So I can say that negative 4 Q plus 120 is equal to 1/3 Q plus 29. Now, what I need to do now is solve down to find what a single Q is equal to. I'm going to collect like terms, moving smallest to largest. I'll start with the Q's. I have negative 4 on the left, positive 1/3 on the right. So I should move negative 4 toward positive 1/3. In order to do this, I'll add 4Q to both sides. That crosses off on the left-hand side, leaving me just 120 is equal to 4Q plus 1/3 Q is 1 and 3 Q plus 29. Now I need to get the numbers on their own. 29 is the smallest, so it moves toward 120. So I'll subtract 29 from both sides. That will give me 4 and 1/3. Q is equal to 120, take away 29. If my arithmetic is half decent, that's equal to 91. Now I need to find out what 1Q is equal to. I know what 4 and 1/3 Qs are equal to, so let's take 91, divide through by 4 and 1/3, and I'll probably be a little bit generous as I round this because I very much doubt that it's going to be a whole number. So let's take 91, divide by 91 divide by 4.33. If I do that, the calculator gives me a long string. I think the best thing to do here is round up to the nearest whole number, given that we're not done yet, so it's nicer to have quite round numbers. We'll say that Q is equal to 21 in this case. Now, I'm now going to take that Q value, which I found, substitute into one of the equations, and that will give me the equilibrium price. Now, I think perhaps the nicest to work with is probably going to be the supply equation. So if I go P is equal to 21 divided by 3 plus 29. That will give me the equilibrium P value. Now, rather happily, I know that 21 divided by 3 is equal to 7. 7 plus 29, again, if my arithmetic isn't too shoddy, should give me price is equal to 36. Now it doesn't give it does give a currency, it's dollars, so that's in dollars too. At this point, I've rather nattily dealt with part one. So I now turn to dealing with part two, calculate the new equilibrium price and equilibrium quantity after the imposition of a fixed tax of $13 per good. and I'm asked to meditate on who would pay that tax. In this case, I'm going to work, because it doesn't tell me directly which side I need to apply the tax on, I'm going to go out on a bit of a limb and apply the tax on the supply side. So as if the government were charging fuel duty or tax on cigarettes, that sort of approach. I think that's the most logical way to approach this. So what I'll do is I'll work on the assumption that the price received by a supplier is going to be taxed by $13. So on the supply side, we'll get P minus 13 is equal to the supply equation given in the question. So that's 1/3 Q plus 29. Now, I should probably tidy that up a little bit. So if I've got negative 13 on the left and positive 29 on the right, I can tidy that up a little bit by adding 13 to both sides. So that will give me P is equal to 1/3 Q stays the same. Now 29 plus 13. So that should give me 42. Again, I'm doing this without a calculator, so I put my faith in my mental maths. So now I have my supply equation. I'm going to make the same equilibrium assumption as before. So I'm going to take my new supply equation, which is 1/3 QS plus 42, set it equal to the original demand equation. So that's negative 4Q plus 120. Now I need to do the same trick again, solve down for an equilibrium. So this time I'm going to take the same approach. So in a similar way, I'll get 4 1/3 Q on the right hand side. And this time I need to subtract 42 from both sides. So again, if my mental arithmetic is not so bad, 120 take 42 should give me 78 on the left hand side. And now I need to get a Q on its own, so that's equal to 78 all over 4 1/3. Now we go for the calculator again, so just let me move it over there. 78 divide through by 4.33. I'm doing the same rounding trick as before. That should give me 18. As the quantity of output, and as you can see, compared to the left-hand side, we have managed to reduce the quantity by applying tax, and that makes absolute perfect sense. So now I need to perhaps zoom out a little bit, just to obtain a bit more space. And I can now work out the new price. I think I'll go for the same trick that I did before of substituting into the the supply side equation, largely because I think I can divide 18 by 3 quite nicely. So the price here is equal to 1/3 QS, that's the same as 18 over 3. Plus 29. So that's equal to, well, 18 over 3 is 6 plus 29 will give us 35 dollars. So I'm now comparing the equilibrium price with the tax, which was $35, with the previous equilibrium without the tax, which was $36. So in this case, I've got a lower equilibrium price. So this means that $1 of tax is paid by the firm. That must mean that the difference is going to be paid by the supplier. Now the tax was $13, so that means that 12 is paid by the supplier. Now, intuition tells me that the tax will usually be borne by the side of the market that has the least elastic demand or supply, and as I can tell from the coefficients in here, let's use green, I have -4 versus +3, so yes, the majority has actually been borne by the supply side because it's the least price sensitive. So if I now zoom out, there we have it, a full and complete answer for question 4. That's from page 38 of the JACAS textbook.